So as we know, we studied in yesterday's class, what is the mass and what is the weight. Of course, already we started Newton's third law of motion also. So actually, Newton has given 3 laws to describe the motion of a body. So that is what we used to call as Newton's first law. And the second one is Newton's second law. And the third one is Newton's third law. Newton's first law will says that it's a very simple. So suppose if there is a body which is in state of rest, and there is a body which is in continuously in what motion, everybody? Continuously uniform motion in a straight line. Uniform motion in a straight line. Unless an external force is applied, I cannot make this body from rest to motion. Unless external force is applied, I cannot bring this moving object to the rest. Am I right, everybody? Clear? Yes or no?
Yes, sir.
That is only first law of motion. Newton's first law of motion. A body which is in rest, the body which is in rest remains in state of rest. The body which is in uniform motion remains continue its uniform motion in a straight line unless they will compelled by an external force. So that is what we used to call as Newton's first law. And this Newton's first law also we can call as law of what, everybody? Law of
inertia.
Law of inertia. So what do you mean by inertia? For example, this body wants to be in state of rest. It don't want to move. So unless if you are applying the greater force than its mass, it has some resistance. It don't want to change it. So that resistance only we used to call as what? Inertia. That inertia is depends on mass of the body. Greater the mass, higher will be the inertia. The resistance force or resistance to change. It don't want to change into motion. Then it will depends on mass. That is what the opposing the change is only called as what we used to call, everybody. The opposing to change is only called as inertia. So that is why we can say Newton's first law also we can call as law of inertia, or also we can call as Galileo law of what? Inertia. Understand? Yes. So because Newton made this law from the Galileo experiment only. We have done and I have shown you. Do you remember everybody Galileo experiment? Yes, please.
Yes, sir.
Yeah, that is why. Inertia means not unable to change position by itself, Mr. Kishore. Opposing force to change. The force which is opposed to change is called as inertia. Purima.
Sir, it is a tendency of the
tendency. For example, you are in a state of rest. For example, you are in a state of rest. You don't want to make into motion, but somebody is pushing you or pulling you. Till where you can resist that? Unless they are applying the greater force than your mass or your opposing force. That opposing to change is only called as inertia. It's a property to oppose the change. That is depends on mass. If your mass is greater, higher will be your having the inertia, and mass is lesser will be the inertia. That is what we can say mass is directly proportional to inertia. Next, Newton's second law, we studied that rate of change of momentum. That is what F is equals to delta P by, what is the Newton's second law? Delta P by delta T. Or we can say, this is actually the universally accepted. Every situation, this is always true. Keep it in mind, all of you. 11th class, you will study again. The Newton's second law, which is always true, is change in momentum divided by change in time. The law which we are writing, F is equals to ma, some situations it is not valid. It is not valid always. Okay, but it is not necessary in class 9. So that you just remember, 11th class you will study motion in a plane. By that time you will understand why it is not valid, why it is valid always. We will get laws of motion. Again, laws of motion, you will get chapter number 4. in class 11th. Presently for 11th, that is what is going on. Even I'm teaching. That's what I'm saying. So this is what Newton's second law. For Newton's second law, you must study the derivation. Do you all clear with the derivation, everybody? I asked you to study recently also. Am I right? All of you? Yes, please. That is what Newton's second law. Now coming to the Newton's third law, as I have given yesterday introduction, Newton's third law will says that every action there is an equal and opposite reaction. But as I told you, action must be taken by one body and the reaction must be shown by the what? Everybody. Reaction must be shown by the another body. Both action and reaction always will take place in how many bodies? Everybody? Two bodies. Understanding? Single body cannot be shown action and reaction. So always Newton's third law is valid when two bodies will hit each other or when two bodies will touch each other or something. Okay. Now I'm saying those who joined late, Mr. Gokul Raj, Mr. Darshan, Mr. So many, Arasani, all of you, please be very serious, be on time and wake up before 5:30. Regularly, I'm saying you, each and everybody. You follow, you follow. If not interested, you can leave. That's all. I'm not having any force to anybody's. Very serious. You have to work. That is what I wanted. Your parents should not disappoint it. Joining now after 15 minutes in meeting. What is this sense? I have sent by 6:02. Now you people are joining. Very, it is ridiculous. It is. You should wait for me and you have to be on time very fast. Mr. Sam, you also I'm saying. Regularly you have to wake up by 5 o'clock. I'll see you every day. Okay. So now in today's class, we are going to continue the Newton's third law of motion. I hope you already kept the heading. Am I right, everybody? Guys? Yes?
Yes, sir.
Yeah. So Newton's third law of motion. So if you have taken Newton's third law of motion, I have given you the statement. What is the statement, everybody? All of you? Yesterday we have written the statement for Newton's third law. What is the statement? For every action, all of you? For every action,
For every equal and opposite
there is
reaction.
there is
Reaction.
yes,
Equal and
there is
opposite
an equal
reaction.
and opposite reaction.
Opposite
That is
reaction.
what we used to call as Newton's third law. So let us consider two bodies. So consider, I am taking, because Newton's third law is always valid for how many bodies, everybody? Two bodies. So I am considering two bodies. Okay. So one is body A and another one is what? Body B. Both are colliding. Both are what they are doing, everybody? Both are colliding. Understanding? Colliding means hitting each other. So if you observe very carefully, so I will take two bodies. One is body A and another body is body B. So the body A, which is shown, which we used to call as action, then the body B we used to call as what? Everybody, which is called as reaction. That is what I said. Action is equals to minus reaction. Action is equals to what? Minus reaction. Minus indicating what? Opposite direction. Opposite. Yes, please. Opposite direction. Okay. Now let us consider these two bodies are hitting each other, colliding each other. So A exert a force on B. Am I right, everybody? A exerts force on B. So that is only we used to call it as what, guys? The force exerted by A on B. That is what? Look into the screen, everybody, how I am writing. The force exerted on B by A, which is equals to what we used to call, Mari, which is known as action. Everybody clear?
Action.
Yeah, please read this one. Everybody read once. What is this statement? Force exerted on B by what? A. Okay, so that is what FBA we used to call that. Same way, according to the Newton's third law, B also will exert same force on A, irrespective of its mass. That B is bigger or smaller or doesn't matter. A is bigger or smaller or doesn't matter. If A, for example, exert 10 Newton force on B, then B also will exert how much force on A? Everybody, same 10 Newton force. Understanding? Irrespective of their masses. So that is what now. As we know, according to the Newton's third law, B also will exert same equal force on A, but in opposite direction. So that is what force exerted by B on A, which is equals to, we is to called as, what is that called as, everybody?
Reaction.
Reaction. Everybody clear?
Reaction.
All of you understand? So that is only we is to called
Yes,
as reaction. This reaction is always what? Equal to action, equal in magnitude. Magnitude is equal, but in what direction, everybody? But in opposite direction. So that is why we used to represent it is with the minus sign. So I will
So
say
there will be any change in direction or any movement.
direction is changes. That is what I'm saying, Mari. But if it is direction of reaction will be opposite. Suppose see the force exerted on B by A, which is equals to minus force exerted by B on A. Do you understand, Mari? Opposite both. Understand? All of you read this statement. See, all of you, again I'm saying F is force. B indicating the experiencing body. Who is experiencing the force is actually left. Who is
Action.
going to exert the force is actually right. Okay, please remember that. Same way, if I write FAB, what do you mean by that? A is left, B is right. So means who is exerting the force, everybody? Who is exerting the force? B. Okay. Who is
B.
experiencing the effect?
Reaction.
Who is
A.
experiencing the effect? A.
Mhm.
You understanding? So that is what. Understand, Mr. Nivedan? What I'm saying? Yes, Mr. Kishore?
Yes, sir.
Yeah, that is what you have to remember. Reaction is equals to action, but opposite direction. So always remember the left indicating the force experiencing by body, right indicating who is exerting that force. That is what you have to remember. So this is what we used to call as action and reaction. So every action definitely it is accompanied by what? Every action definitely it is accompanied by what is accompanied? It is accompanied by reaction. Okay. So every action is definitely, if there is action, definitely there will be a what? All of you. There will be a reaction. Understand, everyone? So we find that forces are always existed, not in alone. Forces are existed always in what, guys? Yes, please. Pair. Understand? So the force exerted by A and force exerted by B, both are always existed in pair, so that a single force cannot be existed anywhere. Always two forces are existed as a pair. One body is to called as action. The first body exerted force on second body is action. Then the second body exerted force on first body, which is to called as reaction.
Our doubt, sir.
Yes.
We can also say minus FBA is equal to FBA, FAB.
How, Mari? That is what you have to be very clear, Mari. The force exerted by A on B is FBA. The force exerted by B on A is FAB. But FAB is minus. This minus indicating it is exerting opposite direction. That is the reason minus I am putting. You understand?
Yes, sir. I'm saying that
Yeah,
we
you can write it. If you want, you can write it. The force exerted by B on A. So you are saying that force exerted by B on A, which is equals to minus FBA. Am I right?
Yes, sir.
Yes, that is what. Then you can see that you can take like this. Then the A and B. The B is exerting force first. I will take this is as an action. Then the force exerted by A on B, I will take it as a reaction. Nothing wrong in that. Both are same. Understanding?
So the action part should be negative as well.
No, action is always positive. Now here action is done by B. First action is done by B and reaction is opposite. That is why reaction is opposite. Understand?
Yes, sir.
So whatever it is, see, people will consider this is positive and this is negative. If you want, you can consider this is, see, this is action and this is reaction. But if you want, you can consider this is action and opposite one is reaction. Nothing wrong in that. Understand, Mari? Both are same. Clear?
Sir.
That minus
Yes,
is only defining the direction of reactant. How, what direction it is acting only decided by that. Clear? Understand now? Everybody understand, Amma?
Yes, sir.
Yes. So
Yes, sir.
action and reaction do not act on the same body. Always how many
Without doubt,
bodies?
sir.
They involved in how many bodies? Everybody. They involve in two bodies. Yes, Mari, ask me.
Sir, we can keep minus on either the side of reaction and action, no, sir.
Mari, always we can put for reaction, Mari. Whatever you decide first. In a given pair of bodies, which is you want action, which is you want reaction, you decide. For reaction, always you should put minus. Clear?
Yes, sir.
That is what. Understand?
Yes, sir.
Okay, that is what. So always remember, pair forces are always not existed alone. Always the forces are existed how? Everybody. Always forces exist in respond Ra. Forces always exist in what? Pairs only. Okay.
Pair.
That is what. Action is one force, reaction is another force. That is what pair. Action and reaction are pair. So forces cannot exist alone. A single isolated force cannot be existed. Always they will exist in a pair. That is why action and reaction cannot be shown on the same body. Always we need how many bodies, guys? All of you. Action is shown by one body and the reaction is shown by, yes, reaction is
Another
shown
body.
by another body. So action and reaction do not act on the same body. They involve how many bodies, guys? They involve
Two
Same
bodies.
two bodies.
More.
Okay. So that is what. So that what will happen? Both are acting. See that this is 10 newtons, opposite one minus 10 newtons. So both are equal and opposite directions. So that both will cancel each other. So that is why you can see it is not required that two bodies should have physical contact to exert even force on each other. That is also you should remember that. Not necessary to contact exerting force on each other. So that is what we used to call as Newton's third law. Every action, there is an equal and opposite reaction, and they do not cancel each other. Please remember that they always will act on two different bodies. They do not cancel each other. Very important. Do not cancel each other. Okay. If suppose 10 and 10, then it will cancel out. Am I right or wrong, Mari? Mathematics we can cancel or not?
Yes, sir.
Yeah, but this is not 10 and 10 newtons and 10 newtons. 10 newtons is equals to what? Minus 10 newtons. Understanding? So that they will never cancel. They do not cancel each other. Okay. Always. And it is not, always remember that physical contact is not necessary. If it is not collide also, the force will exist. What is the example? With physical contact is not required. We have studied in 8th class also. Anybody?
Non-contact force.
Non-contact forces. Physical contact is not required. Can you give any one example for non-contact forces? Gravitational force.
Gravitational force.
Yeah. Physical contact is not required.
Electrostatic force.
Yeah, required that.
Magnetic force.
Yeah, the two bodies should have the forces. The two bodies should have force on each other. Should have force on each other. If they are in physical contact also it will exist, and not also it will exist. Understand everybody? Alvin, clear? Agalya, any doubt you can ask me. Understand or not everybody? So this is what about
Yes,
what
sir.
is Newton's
Yes, sir.
third law, and you can take the examples also. So what is the examples you can take? So there is a, I told you gravitational force. Second chapter, it's a second law itself. I told you. So gravitational force is existed only between Earth and object, or anywhere, any two objects in the universe. Gravitational force. I already taught you. Gravitational force between. Yes, please. Between
Any two objects.
yeah, any two objects in the world. For example, if I take sun and the planet. So if you take this sun and this is suppose Earth, the force exerted by sun on the planet Earth, we used to call as, let me take the force exerted by sun on the Earth. It is actually ES. Am I right, everybody? Then Earth is also will exert the same equal amount of force on the sun. So that is what we used to call as FSE. So both are equal and opposite. Am I right, everybody? Clear, all of you? Yes? Respond, Ra.
Sir.
This is force exerted by sun on earth. This is force exerted by earth on sun. Both are always equal and opposite. They do not cancel out. If they cancel out, what will happen, guys? Anybody can tell? If they cancel out, what will happen? The force is cancelled out. Both will become zero.
Right.
Then no collide. Earth will fall into the universe and sun will also go
No
somewhere.
gravitation.
Yeah, no force of attraction. Then they will never be in
No
a place. Will fall into the space. That is what it will be happening. So that is what gravitational force between the planet and the sun. You can take it as an example of Newton's third law. The force exerted by sun on planets is action, and planets on sun we used to consider as a what? Everybody, a reaction. Okay.
reaction.
And also you can take two magnets. The force exerted between two magnets which are kept apart. Okay, so if you kept two magnets for each other, so definitely there will be a force of attraction between them. If I take one bar magnet, if I take another bar magnet, so there is a force of attraction between them. Then let me take, this is magnet 1, this is magnet 2. The force exerted by magnet 1 on 2, which is equals to the force exerted by magnet magnet 2 on 1. Always one is action, another one is what? Reaction. So that is what we used to call as Newton's third law. So that is why I said force, there is physical contact is not necessary. Physical contact is not necessary to exert the what? Forces on each other. So that is only we used to say Newton's third law. Action is equals to reaction. So always remember, action and reaction do not act on the what body? Same body. Always how many
Same
bodies
body.
required? Everybody? For Newton's third law, how many bodies?
Two bodies.
Required? Two bodies is required. What you have to remember. Anybody having any doubt? You can ask. Clear, guys? Both Hasinis, Mr. Darshan, Harasini, understand or not? That is what it is called as Newton's third law. Now, let us make applications of Newton's third law of motion. Applications of many applications we can make it, but let it be. That is all you can learn it also. Newton's third law of motion. Applications of Newton's third law of motion. Mr. Lingesh and Mr. Sanjay, please be on time. Don't be late. And I'm very, very serious. I will notice it, everything. So now applications, for example. How many of you know cricket? Do you all people know cricket, everybody? Yes, please. All of you?
Yes, sir.
Yeah. So we
Yes,
all know, for
sir.
example, there is a batsman. So there is a batsman and there is a bowler. Now bowler is decided that he wants to make a bounce so that batsman cannot hit the ball, so that he will make a bounce so that ball will go somewhere like this. Am I right or wrong? You all people know bouncing. Everybody clear? No ball,
Yes,
no ball bouncer. Therima? Yes or no?
Yes, sir.
Yeah. Now, if he
Yes.
wants to make a bounce, more big bounce, he need to hit the ground very largely, forcefully, or he need to throw the ball. If you want to make a bounce, what he has to do, bowler, everyone?
There should be more force exerted on the
Yes.
ground by the
So
ball.
he has to exert more force. If a bowler decided to make, understanding? If a bowler decided to make a bounce, what he has to do? A fast bowler has to pitch the ball very, very hard on the ground. He has to hit the ground very, very hard. If he hit the ground very, very hard, hit the ball to the ground very, very hard, then that is what we used to call as action. Then what is the reaction of the ground? Everybody, ground also will exert what? All of you. Ground also will exert equal and opposite force on the ball. That is what we used to call as action or reaction. Yes, please.
Reaction.
We have to call as
Reaction.
reaction, so that the bounces the ball at a desired height. So whatever the height he will decide, if he wants to make it more bigger bouncer, more harder he has to hit the ball to the ground. If he wants to be normal height, slowly. So like that, if a bouncer, if a bowl, in order to bowl a bouncer, if you want to make a big bouncer, a fast bowler has to pitch the ball very, very hard on the ground. If he hit the ball very hard, that is what we used to call as action. Then the ground will exert equal and opposite force on the ball. That is what we used to call as what? Everybody. Reaction. So that the ball will bounce us at a desired height. Is it okay, everybody? Clear? So action and reaction. So that is what applications of Newton's third law. Am I right or wrong? All of you, please respond.
Yes, sir.
Yes, and we all people knows. I think day after tomorrow, 13th, our Indian Space Research Organization, ISRO is going to launch.
Sir, 14th July, sir. Chandrayaan 3.
Yeah, 14th July. I have sent you in the group
13th,
also.
sir.
Do you all remember
14th.
that? 13th, I think 13th or 14th they are going to launch. I have sent you in
14th,
our,
sir.
yes, send you in our group also. Am I right regarding Chandrayaan 3? Latest
Yes,
information.
sir.
Yes, sir.
Yes. So
Yes, sir.
Chandrayaan 3, if you notice it,
Function.
that is what reaction and action. That is what we can take it as a Newton's third law. So every rocket launching is done by our Indian Space Research Organization, ISRO. What is the full form? ISRO means, everybody, ISRO. ISRO means what? Indian Space
Space
Research
Organization.
Organization. So this is what you imagine like a Chandrayaan 3, understanding? So which is going to launch soon from India. So this is what will work with the principle of Newton's what law?
Third law.
Newton's third law. So how, sir? You can see. So when the fuel of a rocket is ignited, you can see here, the fuel is started burning or ignited from the nozzle backside. You can see in the engine part, a huge amount of gases will come out. That is what expelled gases. Large amount of gases will be released by that. That is what we used to call as action. What we used to call, everybody? We used to call as action. So large amount of, huge amount of gases escape with a extremely high velocity. What will happen, everybody? Extremely high velocity through the opening. What is the opening we used to call as? N. That is only we used to call as nozzle. What we used to call, guys? Nozzle at the rear end. This is called as rear end of a rocket. Rear end of a rocket. So extremely high gases will release. So the force on the gases forms. What it will forms? The force on the gases is only we used to call as. Everybody, please respond. Force on gases is called as what? Force on the gases is called as what? Action. Clear, everybody?
Action, exactly.
So if the action, gases are acting downward direction, action, then what will happen? The burnt gases in turn, they will exert a force in opposite reaction, opposite direction on the rocket. That is what we used to call as what? Everybody. That is only we used to call as respond. Reaction. Clear? So they are equal in magnitude, but in opposite direction on the rocket. So this is actually we used to call as reaction force. This reaction force only, acceleration of the rocket keeps on increases. The rocket velocity is also keep on changes. That is what acceleration of the rocket keep on increasing as the mass is constantly reduced. When it will go to one level, all of you remember, rocket parts are removed one by one. You all people knows, I think. You might be all followed in a Google. Am I right, everybody? After certain level, for example, from the earth, if it will reach it to certain level, some body part automatically will remove. After certain level, yeah, dispatching. Other body parts will release. After reaching to the orbit, only satellite will be there. Remaining all the parts will be falling. Am I right or not, everybody? Yes, please. So that when it is bodies keep on going up, the mass of the bodies keep on decreasing. If the mass of the bodies keep on decreasing, acceleration increases or decreases. Force is equals to ma. Acceleration is equals to F by m. Acceleration is inversely proportional to mass. Now tell me, mass is keep on decreasing, so that acceleration keep on increases or decreases. Everybody.
Increases.
Yes, please.
Increases.
Increases. That is
Increases.
what will happen. So that is how the rockets will work. Rockets also will work with the principle of what? Newton's? All of you.
Sir, can you
Third
please
law.
define that again? Sir, can
Yeah.
you please define that?
Newton's third law. All of you remember? From the nozzle, rear end of the rocket, the gases will be released. The gases are ignited, and these gases are extremely high velocity. These gases will come with the extremely high velocity. So the force on these gases actually forms an action. So these gases actually, what will happen? They will turn and they will exert a force equal in magnitude, but in opposite direction. That is what we used to call as reaction force. So this reaction force continuously acceleration of the rocket keeps on increases. It will increases the acceleration of a rocket as the rocket is keep on going up from the down. Elevations, height is increasing, height is increasing, height is increasing. What will happen? The body parts of the rocket will be keep on removed. Automatically, they will be dismantling. So at certain level, something will remove. At another level, something will remove. Like that, entire body parts is slowly reducing. So as it is, mass of the rocket is reducing. What will happen? Acceleration of the rocket will be keep on, everyone,
Increasing.
keep on increases.
Increases.
As the mass is constantly reduced due to the burning of the fuel. As the fuel is keep on burning, the mass of the rocket is keep on decreasing, so that the rocket acceleration is keep on increases when it is going above from the ground continuously. So that is what we used to call as applications of Newton's third law. So in every rocket, every country, whatever they are doing, it is only because of Newton's third law. Action is equals to reaction. Here, action shown by the gases, the fast moving gases is actually action, so that they will exert the same equal amount of magnitude of same magnitude of force. They will exert on opposite direction. That is what on rocket, so that the rocket will keep on going up with the increasing acceleration. Is it all okay, everybody? Increasing acceleration. Why the acceleration of the rocket will keep on increases? Anybody will ask you. What you people will say? Why the rocket
Because
acceleration
it's
is keep
inversely
on?
proportional to mass.
Because the mass of the rocket will be keep on decreases. Do you understand,
Decreases.
Kavya? Acceleration of the rocket keeps on increasing as the mass constantly reduced due to the burning of the fuel. Is it okay, guys? Everybody? Mr. Darshan, Laksha, Abhirami, understand? So these are the applications. Of course, many applications we have. Everything is action and reaction. Even you are walking, for example, walking on the ground, you can see you people are pushing the ground in a backward direction. That is what we used to call as action. So that the ground will exert the same force in opposite direction. That is what is reaction. So if the ground action between the legs and the ground, reaction between the ground and the legs, then it is impossible to walk. Do you all understand, everybody? All of you? Impossible to walk, impossible to run, impossible to jump, or whatever it is. If you push the ground in a backward direction, that is what we will say action, then ground will push us forward direction. That is what we used to call as reaction. So many places you can take. Swimming, for example. You suppose there is a water, so one boy is keep on swimming. You can see with his hands, he will push the water in a backward direction. That is what we used to call as action. So that water will exert force on him in a forward direction. That is what we used to call as what? Everybody. We used to call as respond, Ra. We used to call as
Reaction.
so like that. Everything there will be action and reaction. Newton's third law, we can form many examples. For example, a bullet is fired from a gun. A bullet is fired from a gun. You can notice it. The force exerted by gun on bullet, we used to call it as what? Everybody. The force exerted by gun on bullet, we used to call it as what? All of you? We used to call as action.
Action.
Then bullet also will exert force on the gun. That is what we used to call as what? All of you.
Reaction.
Called as.
Reaction.
So like that, everywhere, every point will be having action and reaction. Is it all okay, guys? Everybody clear? All of you? So this is what is the applications of Newton's third law of motion. Meeting is going to end, join back so that we will study what is conservation of momentum. Then tomorrow's class we will discuss verification